In this assignment, you are supposed to take the last digit distribution class from this worked example and turn it into one that looks at the distribution of the initial digits. So let's have a brief look at the worked example. So in there, we have a class last digit distribution, and it analyzes sequences. So the key method here is the method process, and it gets a value of some object of some class that we don't know, but we know it implements the sequence interface. And we're told how many values we are to extract from that sequence. So this last digit distribution object has a bunch of counters, and we take the next value from the sequence, not knowing how the sequence produces it, but we don't need to care. We extract the last digit, and then we increment the counters. And then there is another method that prints all the counters so that they look like this. So the key observation here is that the last digit distribution class has no idea how the sequence works. So now we're supposed to do the same thing with the first digit instead of the last digit. And like it says in the problem, there's actually a good reason to do that. People do this in real life because unlike the last digits, which are pretty randomly distributed most of the time, the first digits are definitely not randomly distributed. So here I have some real data that I got from that Fount of Wisdom Wikipedia, the heights of the 50 or so tallest skyscrapers. And when you look at the first digit, you'll see a bunch of 8s and 6s and 1s here, lots and lots of 1s, of course. And so it makes you wonder, that is 1 more common in just real data? And the truth is it is. Here's another set from rivers. And again, you see there's lots of 2s and 1s. And there's fewer 8s and 9s. And that just turns out to be generally true. It's called Fitt's law. And it has been used by people to detect accounting fraud. If an accountant makes up numbers completely randomly, and if they're not aware of this, then they are more likely to come up with numbers where the first digit is in fact randomly distributed, where 9s are as common as 1s. And when someone finds that, then they know that the books have been cooked. So what do we need to do? We need to do a few things. We need to change from the last to the first digit. And the other thing is, these sequences are finite. Obviously, there are an infinite number of squares, but there's only a finite number of rivers. And so we need to change the interface type to account for finite sequences. None of this is very difficult. It's just, there's a bunch of fiddly details to get straight. So first of all, here's the sequence interface. And what we need to do is add that hasNext method. That method is true when the sequence has more to offer. What about for the squares? For the squares, there's always a next square, so hasNext will always return true. Now in the first digit distribution class, there's two things we need to do. One is we need to handle first digits. How do you get the first digit of a number? What I simply do here is I keep dividing by 10 while the number is greater than 9. So, for example, if you have a number such as 2456, I would divide by 10, that gives me 245. I divide by 10, that's 24. I divide by 10, that's 2. Oh, that's now less than 9, and so 2 is my first digit, and so that's the one that I take in here to increment the counter. So handling the first digit is not particularly difficult. There's, of course, any number of other ways of doing it, but this one looks simple. The other thing I had to do is I had to make sure that I only keep extracting values while the sequence tells me it has more values, since now some of the sequences that we have are finite. Which sequences are finite? Well, those are the ones that come from real data. So that's the data sequence here. And so it reads from these files. Let's have a quick look at one of these files. So you'll notice that there is some amount of text, which may or may not have spaces. Then there's a colon, and then there is an integer after that. So we need to read a line. That's here. We then need to go to the index of the colon and go one beyond that. So that would be this position here. Then we extract the stuff here, and that's with the substring command that you see here. And then I'm a little nervous that what we might be getting has some white space around it, so I trim off the white space, and then I feed the whole thing to integer parseInt. Now I put this all into one long thing here, and is that great practice? I would say for an experienced programmer this is fine. If you broke this up into a bunch of little steps, that's perfectly fine as well. It would probably make it a little easier to read. So that's how we get the next value in the sequence, and the hasNext method simply calls hasNext line on the scanner. So notice that this data sequence is not actually reading all of the data at once. It is reading the data on demand. Every time next is called, a new element is read in. So in order to do that, of course, it needs to hang on to the scanner with which it was constructed. Finally, notice that data sequence must, of course, implement the sequence interface. So if you look at this, no one part of this solution was very difficult, but there's just a lot of little things that one needs to keep track together, and that's the complexity that we're now running into. Unlike the issue with loops, where you had very difficult algorithmic challenges, here the challenge is more to just keep all the balls in the air and understand the interrelationships between the classes and the interfaces.